You've probably noticed that when you're typing a text message, your phone suggests the very next word it thinks you're about to use. The massive AI models that can summarize entire news reports, known as transformers, are essentially just incredibly powerful versions of that same autocomplete technology. Their core function is actually quite simple. The model looks at a sequence of words you've already provided and calculates the mathematical chance of what the single next word should be. This simple next word prediction is the foundation for how an AI can process thousands of words and condense them into a few important ideas. But if an AI's only instinct is to predict the next logical word, how do we force it to write a short summary instead of just continuing the original article forever? Without a special set of rules, the AI doesn't understand the concept of a summary. If you give it a news story, it will just keep generating more sentences in that same style until it runs out of space. To solve this, we don't actually change how the AI works. Instead, we have to find a clever way to format the information it practices on so it learns exactly when to stop reading and start summarizing. To teach the AI, we start by taking a full news article and gluing a human-written summary directly to the end of it, creating one long document for the model to study. To keep things organized, we separate them with a special tag called an EOS, short for end of sequence. It acts like a clear stop sign, telling the AI exactly where the article ends and the summary begins. Computers don't actually read English words, though. To process this document, every word and tag has to be translated into a format the machine understands. This is the tokenized version of our data. As you can see in this list of numbers, every word and tag has been replaced by a specific ID number. This turns the entire document into a long sequence of integers that the AI can calculate. This long string of numbers is the raw material the AI uses to practice its reading and predicting skills. During training, the AI looks at this string of numbers and tries to guess every single word from start to finish. But to help it learn, we have to act like a teacher grading its performance. If we grade the AI on how well it memorized the original article, it won't learn how to summarize. We need a way to tell the AI that we only care about the quality of the summary at the end. We do this using a scoring system called weighted loss. It's a mathematical way to tell the AI which parts of the test actually count towards its final grade. Here's the trick. We assign a weight of 0 to words in the article section. Those mistakes don't count. We assign full points to the summary, forcing the AI to focus its learning there. A tiny score like 0.2 helps vocabulary, but 0 is standard. By zeroing out the grade for the article, we've successfully trained a simple next word predictor to behave like a laser-focused summarization machine. Now that the AI is trained, we move to the inference phase. This is just the technical term for putting the model to work on a brand new article it has never seen before. Look at the model input section here. We provide the new article, add that end of sequence tag, and leave the rest blank. That tag is the trigger that tells the AI to start summarizing. The AI reads the article, hits the tag, and creates a list of possible next words. It's like a spinning wheel where likely words take up more space. It spins the wheel and picks the first word. It feeds that word back into the sequence to guess the next, continuing this loop until it hits the final stop tag. Because the AI is picking from a range of likely words, if you run the exact same article through it twice, it might choose slightly different paths, giving you a fresh summary every time. The magic of AI summarization is actually just a high-speed loop of a model picking one logical word after another based on the probabilities it learned during training. By turning text into numbers, using a weighted grading system and a fast probability loop, we turn a simple predictor into a powerful tool. It turns out that the complex AI capable of digesting massive amounts of information is built on the exact same foundation as the autocomplete on your phone.